Okay, so tonight what we're going to work on are finding zeros of a polynomial, and given the zeros of a polynomial, write the equation of the function. So I'd like you to put me on pause, do the try this, which is find the degrees of the polynomial, and then come back and check your answers. Okay, so remember the degree of the polynomial is its largest exponent. So look at the first one, f of x is equal to 3x plus 2. Its largest exponent is 1, so it's a first degree polynomial. Okay, let's take a look at 2. So it's x plus 2 squared, which is x plus 2 times x plus 2, which will give me an x squared when I double distribute. So this is a second degree polynomial. Let's take a look at number 3. I have x times x plus 2 times x minus 2. So when I distribute here, the first part I get x squared plus 2x, and then times an x minus 2. And when I double distribute, I'll get an x to the third there. So this is a third degree polynomial. And let's take a look at 4. So I have an x plus 2 squared, which is x squared plus 4x plus 4. And x minus 3 squared, which is x squared minus 6x plus 9. And then when I distribute that, I'll get an x to the fourth. So this is a fourth degree polynomial. Okay, so the zeros of a polynomial. The zeros of the polynomial is where the graph touches or crosses the x-axis. So it's where the graph touches or crosses the x-axis. All right, so where it crosses the x-axis would be when f of x, which is your y value, is equal to 0. Because remember, where something hits the x-axis, all the y values are equal to 0 there. All right, so then what do we know is that when a polynomial function has a degree of n, it has at most n real zeros. So, for instance, let's take a look at number 3 here. It has a degree of 3, which means it will have at most 3 zeros. It might have 3, it could have just 2, but it'll have at most 3. It won't have 4. And it has at most n minus 1. So in this case, n minus 1, so that'd be 3 minus 1, which is 2. It'll have 2 mins or maxes, which are called extremas. Okay? All right, so let's draw a couple pictures and we're going to write down some information. A first degree polynomial would be a line. Okay, so this has 1, 0. Okay, it has at most 1, 0, I should say. It has 0 extrema. Has no mins, has no max, right? Because if I have 1, 0, that means my degree is 1. And remember this, n minus 1 will give me how many extremas I can have at most. So 1 minus 1 would be 0. I would have 0 extrema. A degree 2 would be possibly a parabola that looks like this. So this would have 2 zeros. It has 1 extrema. So if it has 2 zeros, if it has 2 zeros, that means my degree is 2. So 2 minus 1 is 1, which means I have at most 1 min or max. A degree 3 polynomial would look like this. And this would have 3 zeros. And that would have 2 extrema. A fourth degree polynomial would look like this. Something like this, anyway. Okay, so this has 4 zeros, right? Crosses the x-axis 4 times, which means it has at most 3 extrema. So these are just types of degrees of the polynomials. There are variations. So variations of equations will result in less zeros or extrema. So for instance, you can have a degree 2 polynomial that looks like this, that comes down and hits the x-axis, comes down, hits the x-axis one time. So we know a parabola is an x squared. So this has a degree of 2, but it doesn't have 2 zeros. It only has 1 0. Okay, so what it means is it has at most 2 zeros. Could have less. All right, so it depends on what the equation is. All right, so let's move on down. So it says real zeros of a polynomial. If f of x is a polynomial function and a is a real number, which means it can't be imaginary, then this is what I know. X equals a is a 0 of f of x. X equals a is a solution of the polynomial f of x equals 0. I also know that if a is a solution, a is a 0, then x minus a, right, subtract a from both sides, would give me a factor of the polynomial. And then I also know, since it's where it crosses the x-axis, then my x-intercept has to be a comma 0. All right, so I want you to solve this. I want you to find the solutions of x to the 5th power minus x. So this is one thing I know before I even solve this. I have possibly 5 zeros. Okay, so I want to find my zero. So I know f of x, not f of x, sorry, that x to the 5th minus x has to equal 0. All right, so I have a GCF. GCF is x, so I have x times x to the 4th minus 1. And then I can factor x to the 4th minus 1 is the difference of two perfect squares. So it's x squared minus 1, x squared plus 1 equals 0. And then I can factor x squared minus 1. So it's x plus 1, x minus 1. I can't factor x squared plus 1 because that's not the difference of two perfect squares. All right, so these here, this section right here, these are my factors. Now, when I draw my t-chart, I do this. Now I'm going to find my zeros. So I have x, so let's just take a look at this one here first. X squared plus 1 equals 0. So when you minus 1 from both sides, you get x squared equals negative 1. Take the square root of both sides, you get plus minus the square root of negative 1, which is I. So this here would be no real roots. No, not real roots. All right, and then here I have x minus 1 equals 0, so x is equal to 1. X plus 1 equals 0, x equals negative 1, and just x equals 0. So what these are here, these are my zeros. So how many zeros do I have? I have 3 real zeros. So it crosses the x-axis 3 times. What else? One of the other things that I know is, besides that I have 3 real zeros, and these are my zeros, right? These are my zeros. These are my factors. These are my solutions. I also know my intercepts. My x-intercepts are 0, 0, negative 1, 0, and 1, 0. Okay, so now over here on the right, if you're just giving the roots, negative 5 and 9. So I'm giving you this here. So this is what I know, that number 1, I'm going to move all this stuff out of the way actually. All right, so one of the things I know is this. 1, x equals negative 5 and x equals 9 are zeros of f of x. Another thing I know is this. X equals negative 5, x equals 9 are solutions of f of x equals 0. I also know this. Number 3, sorry. That x plus 5 and x minus 9 are factors. And the last thing I know is that, I'm just going to change the color here. Number 4 is that negative 5, 0, and 9, 0 are my x-intercepts. Okay, so let's flip it over and take a look at the back. Okay, so if you want to find the function, the equation that matches up to these zeros. So when you have real rational zeros, then what you want to do is you want to work backwards at factoring. So if these are my zeros, then I know x is equal to -5, x is equal to 3/4, and x is equal to 0. All right, so now I'm going to get them to equal to 0 because I'm just doing backwards of factoring. So I do x plus 5 equals 0. This here I'm going to multiply both sides by 4, so I get 4x equals 3. Minus 3, I get 4x minus 3 equals 0. And then I still have just x equals 0. So now I have my factors. My factors are x plus 5, and 4x minus 3. Okay, so now I'm going to distribute. So I'm going to multiply x times x to get x squared, and x times 5 is 5x. Now I have to multiply that times 4x minus 3. Okay, so we have x squared times 4x is 4x to the third power. X squared times -3 is -3x squared. 5x times 4 is positive 20x squared. And 5x times -3 is -15x. And then when I combine like terms, I get 4x to the third. So -3x squared plus 20x squared is positive 17x squared minus 15x. And since it has to be an equation of a function, it's f of x equals 4x to the third plus 17x squared minus 15. So you have to make sure that you do have this f of x equals. Okay, so that's when you have real rational zeros. Now, what happens if we have irrational zeros? So what we're going to do is for this, because you see I have irrational roots here, is we're going to use the completing the square backwards. So I just want to review completing the square so we have something to reference. So I want to find my solutions here. So it's x squared plus 8x minus 3 is equal to 0. So I add 3. I get x squared plus 8x is equal to positive 3. I do half of 8, positive 8. I get positive 4 squared is 16. Add it to both sides. X squared plus 8x plus 16 equals 3 plus 16, which is 19. And then I factor. Remember, I get my parentheses squared. So we get the same thing. Two of the same parentheses. It's x plus 4 squared equals 19. Square root both sides. We get x plus 4 is equal to plus minus the square root of 19. Minus 4. X is equal to -4 plus minus the square root of 19. Okay, so what we're going to do now is go from here back up. All right, so let's start by writing out our zeros. Just going to move this over a tiny bit. So I have x is equal to 3, and I have two solutions here. Right, so I have 3 solutions, so I know my exponent when I'm done, I should have at least an x to the third power. All right, so I have x is equal to 2 plus minus the square root of 11. All right, x equals 3, so I know minus 3, I get x minus 3 equals 0. There's one of my factors. All right, so now let's start working with this one on the right. So I can't do anything with this until I get the factors for this guy here. All right, so I'm going to minus 2 from both sides. X minus 2 equals plus minus the square root of 11. All right, so now I want to get rid of the square root. So to get rid of the square root, we square both sides. So when I square plus minus the square root of 11, I just get 11. And the reason why it's not plus minus 11 is because when you square a negative, it's positive. When we square a positive, it's positive. So that means it's still, both of them are just positive 11. All right, now x minus 2 squared is x minus 2 times x minus 2, which is x squared minus 4x plus 4. Now minus 11 from both sides. We get x squared minus 4x minus 7 is equal to 0. So here's my other factor. X squared minus 4x minus 7. And then I have this factor here, x minus 3. All right, so I'm just going to move everything up a little bit so I have a little bit more room here. Okay, so now I need to multiply my trinomial times my binomial. All right, so I'm going to just write it as x squared minus 4x minus 7 and x minus 3, and now multiply. So we have positive 21, positive 12x, and negative 3x squared, negative 7x, negative 4x squared, positive x to the third power. Add them down, we get 21, positive 21. Positive 12x minus 7x is positive 5x. Negative 3x squared minus 4x squared is negative 7x squared. And then we have x to the third. And remember, that has to be equal to 0. So don't forget to put the equal 0 at the end. Okay, so it equals 0. All right, so that's it. And we'll practice in class tomorrow. Have a good night.